Welcome back to the last session of the day, where we have the panel discussion on the possibility of integrating system approaches into EU product policy. We first have an introduction by René Kemner on how, and he will talk about how far the current methodology used for Ecodesign and energy labeling covers systems and if it could do more.
Okay, thank you, and thank you for inviting me in this illustrious company. I didn't know I was to do an introduction to a panel session. I just prepared my lecture, but I hope it's okay anyway, because we'll be touching on most of the subjects that we've seen. As many of you know, we are involved in the methodology for Ecodesign, and that's probably one of the reasons why I was invited here. And that's also the reason for this title, which was forced upon me. It's a nice, catchy, short title. Does it work? Yep. So, current methodology. I think I'm going very fast on this part, which most of you will know. The methodology for doing preparatory studies for supporting the Commission and decision makers, member states. The MIRP, the methodology for eco-design of energy-related products. It was developed mostly over the year 2011, and it built on the MIUP, which was for energy-using products, which was developed in 2005, and has been used with most of the products which have led to legislation today. It consists of three parts, this methodology, which is the one that most new studies will follow. The methodology part, a part on data, reference data, and a Excel tool, Eco Report. The methodology, as far as system approach is concerned, on task 3, looks at, as the name says, no longer just the energy-using products, but looks at 3 varieties of energy-related products, which still include the using products, which could include products which don't use energy themselves but induce energy use in others. And the third category, which both use energy themselves and cause energy use in other products. This has been shown before by Robert, amongst others. There is a strict scope where you just look at the steady state operation. An extended product approach whereby you are looking at part loads, the possibility of controls, the whole system where you would actually include the controls and related products in the whole, let's say, evaluation of the product. And you would have an approach whereby you compare this product as such, as a technical system, to other technical systems. Now we didn't do this on purpose, Robert. Is the same slide, but so you know it. But it illustrates, for instance, natural ventilation as a system versus mechanical ventilation as a system, and actually gives a sort of reference for one for the other. This is a part also of the MIRP study, the reference data. It shows you. This is the segment about electricity, and it shows you actually the order of conversion from component level to assembly level to final product level. You could be happy to look it up. I'm not going to spend lots of time explaining the whole thing, but it's been most useful. I think it's probably the most useful part of the whole methodology study, because I see it hanging on the wall with most of the Commission policy officers who are dealing with this. So. One picture, 1,000 words, that sort of thing. Okay, the approach with an indirect product is a little bit different than the one that the tasks are a little bit different from the one with an energy-using product. And actually, you just have to multiply the amount of data gathering by at least factor 2 or 3, and sometimes even much more. Just some examples. So this is one where the product itself doesn't use any energy, but it induces, of course, the energy of something else, with building insulation materials, for instance. Relatively simply, the energy using system is the heating system, of course, and you look at the transmission losses of the non-transparent parts of the building as a countermeasure. So this, from the methodology point of view, is relatively simple. We're going to a subject which is currently being studied, which is windows, which is by no means simple, which at least deals not just with the transmission losses of the window, but also of the losses for the lighting system. So the more panes you put in there, 3-pane type of windows, you lose around 30–40% in light in your interior, which probably you will have to fill in with artificial lighting systems. So these are the simple formulas that will deal with that. If you're interested, you can read it on the slides, but I'm not going to spend too much time on that. The second report, and I'm going to say a little bit more about this later, gives you a sort of summary of all sorts of reference data. The intention here is that given that there are so many more studies which are going to have so much more data, that at least they could have a simple reference to the MIR part 2 and say, okay, according to this MIR part 2, the energy use of hospitals is that and that and that, and the ventilation is that and that and that. So it's actually a sort of reference volume, which is, I think, a part which is growing much more important. Finally, there is an eco-report tool, which has been extended, which looks at the energy use during use for the energy using products, but it also gives you a little bit more flexibility than the old tool with respect to the end-of-life situations. And I've already heard complaints that it's too flexible, but okay, you know, it's difficult to please everyone. Could we do more? And the answer is, of course, not simple. I think the new methodology, and I have to say I thought it was like a simple 2011 update of the 2005 methodology which we made and which seemed to work and so on. But actually, everybody put their wish list forward, like, okay, we want the methodology to do this and this and this and this. So it is certainly, at the moment, I can really say, flexible enough to accommodate any type of technical system that you would want to accommodate. So in the methodology itself, I don't see any big problems. But what is behind the methodology is something else. What we already see with many, many products which are complicated, ventilation systems is, for instance, one, that you need experts to be able to judge what is being proposed. And it's no longer enough, okay, to have some sort of layman's knowledge of what is a ventilation system. I mean, of a fridge and a TV, you can still, as a decision maker, you can still say, well, you know, I know what it is, I use it every day, so I have an opinion on it. On a ventilation system, or even a more complex heating system, you don't. And okay, I'll come back to that, but capacity building and support is really vital in this if you want to make progress. The second thing is that reference data. Just a very simple example. We don't know, in Europe, we are regulating everything, EPBD, whatever, Robert made a very nice overview. We don't even know how many square meters of building space we have. We have rough estimates, plus or minus 20%. So our legislation will be plus or minus 20% okay. Yeah, but we don't know the building volume. We have nice estimates, but we don't know. So we're talking about something which is the biggest energy using entity in Europe. We have no clue, a little clue anyway, what it is. So that is really, really important. Another thing is that because we don't know what it is, we're always fighting over it. So apart from the fact whether something is really true, we need something which is really accepted by everyone. Otherwise, a lot of the decision makers will spend a lot of time on things which, you know, if it was like 30 million square meters or 28 or even 25 million, it wouldn't really matter. But still, researchers spend a lot of time on these things. And in the end, nobody agrees. The third thing, really boring, nobody's interested, but we have test standards, and without those test standards we can't really do very much, at least not in legislation. Okay, so here we are, and we are looking at a system approach. We're trying to challenge the smartest minds in R&D. People who have had university training as engineers, as physicists, who have then had 10, 15, 20 years of experience in the product sector. And as a legislator, we're trying to challenge them. We say, you have to do something new, you have to innovate, etc. So how can you do that without proper support? It's impossible. It's really impossible. You have to prepare the market, mobilize buyers, market forces, to be ready for these ideas. Now, how can you do that if you haven't got a clue about marketing or communication or whatever? So you need a proper support, not just from a very interested person, not even from a very brilliant person, which there are many around in this decision-making process, but you need really specialists and experts, more than today. By the way, I think on all these issues, not that they're lacking, because I see that there's progress being made, but they should be much stronger. And if A and B goes okay, we want the industry to make the investment in these new products. So we really need to address what industry thinks is important in terms of profits and so on. So there's nothing, I mean, I've heard the word simple. Sorry, Colin. We should do things simple and so on. It's like saying to NASA, you know, you guys rockets to the moon. So do it simple, you know. There's nothing simple about this, if you want to do. Okay, you might have simple concepts, etc. But there's nothing simple. I think the word should be banned, really, from these discussions. And I'm not even addressing some market surveillance issues, which are even a multiple of difficult of what you have when you're talking about system approach. Reference data. Okay. When you are looking at something like Windows, your information needs are going to explode. You need to know so many things about so many issues that a lot of the time in the methodology and in the study is going to be spent on getting at least a grip on what you're talking about. So this is really a big problem. The MERP2 report was a beginning, but building databases which are robust and where people can agree on is really, really important. Now, once you have these huge databases, the next step is to make them understandable. So, not just having huge amounts of data and say to the people, you deal with it, but to get them into simple concepts which can be communicated to the outside world, because in the end, it is a political process, it's a democratic process, so you have to be able to simplify something. At the same time, of course, it has to be backed up by real data. So it's like top-down and bottom-up approach. I think the bottom-up always makes English people laugh, but anyways, don't want to go into that. So, actually, if we would have a reference EU building system, if we would know the average building, I'm not talking the average dwelling, the average building even, and we would have all the data of that, we would say, okay, this is the building that you have to optimize. 30 million square meters, or, I don't know, 110 billion cubic meters. People would have an idea, okay, we are working on this. It might be 10% wrong, it might be 15% wrong, but as long as we agree on, okay, let's try to optimize this one system that we can visualize, it would help people. Okay, and then later on you can subdivide it in healthcare, in education, and then whatever. But, you know, one simple concept where people can discuss about. Same about the food system, where you would say, okay, not just looking at the fridge, we are looking at food preservation over the whole chain. So once you optimize here, you're going to sub-optimize there. So how does it really work? Fresh food, is it a good thing? Is it not a good thing? Does it cost a lot of energy or not? let's say a cold box is really the best way to optimize for energy efficiency and for food preservation at the same time? Probably not. I mean, there's lots of fruits and vegetables in my fridge, I have to say, which go rotten and which would not be rotten when they were outside the fridge. But we have no other place to put them, so we just put the tomatoes in the fridge and the strawberries and that sort of thing, which shouldn't go there. So, the textile system, and we're talking about washing machines, but ironing, but also, like say, clothes themselves. They are all working together, and it could well be that you will optimize for the one and you sub-optimize for the other. The data that goes with it makes people want to think, aha, really, this is what's going on. Thirdly, we're talking about information communication. To have this one system. Now that's a little bit tricky, but because the talks about people staying at home, working at home, instead of traveling, have been there for a very long time and have not really materialized so far. So there are many more mechanisms to understand about, but at least when we have the data all together and we can discuss a simple summary of what's going on, perhaps we can make a better progress and we can make sure that we are going in the right direction. Well, test standards. I think this is a really practical issue. When you're talking about products in systems, you're talking about flexibility, you're talking about adaptation, you're talking about sensors, actuators, intelligence, and what have you. So, in order to verify whether a product has these things, you have to design test procedures for them with multiple tests or duty cycles. You have to make a calculation method which fits. Now that's really, really difficult, but above all, it's very, very slow because you have to test it all. You have to see whether the tests can be reproduced, what is the accuracy, and so forth. So just as a slight illustration of where we have made progress and how long it took. Electronic displays, I think Hans Paul you would know. Discussions about dynamic testing of the image started in the beginning of the year 2000, 2004, I think. So anyway, more than 8 years ago, that's what I want to say. On washing machines, we had one full load test in the beginning of the 90s at 60 degrees. It took like probably some 10, 15 years, but I would say more than 6 years here to get to a new standard for half load testing, for 40-degree testing, and so on. There's actually good reasons for that. Huh? I mean, I'm not going to fill the whole time with that, but there are good reasons for these long times. For vacuum cleaners, I mean, you know, this is probably going to be one of the success stories of Ecodesign, vacuum cleaners. And not just because Matteo is in the room, but these appliances, which were 800 watts and so on, when my mother still had a vacuum cleaner, and it was a fantastic vacuum cleaner, and then they're now moving towards 3,000 watts. Why? Because watts is similar to performance. You know, the more watts, the better. This is rubbish. Really rubbish, but there's no alternative. Now that we have an alternative, we have a label for it, I think we'll go back to 800 watts or less, or 600, what have you. There is no limit to that. And don't think that they're using little, because they're on the same page as washing machines, but at the moment vacuum cleaners are using the same as washing machines. Washing machines going down, vacuum cleaners going up. They're higher on the priority list than you would think. Now, for water heaters, that's really one where I'm pleased to say that, because I can prove it, that it took more than 20 years, because the first mandate to harmonize all the test standards was from 1993. So, really, and it's still not done. I mean, there's still protests everywhere. What you want is a really simple tapping pattern, a duty cycle which simulates an average usage of hot water. Same for electric and for gas appliances. That's what you want. And I'm going to go to the next slide. So there are plenty of problems here if you want to really go into system approach. It's not so much about the methodology, it's technically much more complex. It requires really specialist technical know-how and creativity, and no matter how many times you say simple, some things are not simple. Having said that, you have still to communicate it at some point. You can't just say, well, just lock a few technicians in a room and whatever comes out of it, we're okay with it. No, it has to be communicated, which is an extra effort for something so complicated. The test centers have to be speeded up in one way or the other. I mean, there's progress there, but still. What you would also expect is that things cannot go in one go. I think I've heard already, and many of you have heard criticism about the new space heating boilers, lot 1, lot 2, and so on. And they're all, or most of them are okay. I'm okay with that. But sometimes you have to recognize that to change people's hearts and minds takes decades. And if you speed it up, it takes maybe 5 years. So what I think is that the review process will be much more important with these things that you're doing for the first time. And there's nothing to be ashamed of. You make mistakes and you correct the mistakes. I mean, that's very normal. I know it's in politics, it's not done, but it's very normal. And you shouldn't be ashamed of that, especially with the system approach. Now, okay, communication, general public is important. And last but not least, with many of these things, you are depending on not so motivated, not so knowledgeable installers and people who would not care less about energy. So you're not talking to an R&D department of an industry anymore, or to a marketing department. You're talking about the plumber around the corner, which might have a role to play in that. And this is very, very different. Okay, so, but there are nice things that could be done. I tried to make some rules. I made them up this morning, so it's not really the fruit of years of study. 3 musketeer principle, all for one for all, so no sub-optimization of certain components. Try to look for synergy, but they should at least all work together for the same goal. Low exergy when you can, peak performance when you must. I think exergy is, in this room, most people would know, but it's the ability to do work rather than just the energy. And so I think the standard example is that there is much more energy in the ocean than there is in whatever, all the power plants put together. But we can't do much with it because it's only a temperature difference of a few degrees with ambient. Same here, low temperature, I'm not talking about heat output, low speed, heat recovery becomes possible at these low exergy levels, and hybrid solutions, one for the peak and one for the normal. And third, the Bauhaus principle, less is more. So the right performance, tuned to comfort and functional improvement at the right amount, at the right place, and the right time. Some examples. So yeah, I think Annabelle said it. There are plenty of single-speed motors, but there are very few single-speed applications. So there is a problem there. Information and communication devices, they are not meant for themselves, for boxes, but they're meant for humans. And humans would like things to be small and handy and not have all these boxes around, but just one box is enough, if you can. Exergy, as I said, closer to ambient is good, further away from ambient temperature is not so good. Then I think Annabelle also mentioned it, you have the fan laws, you have the pump laws, which tell you that the relationship between the power and the flow is not linear, but it's roughly quadratic. When you're looking at washing machines, you see that the main reason for energy saving has been lower temperature at the expense of more time, more mechanical action, more chemical action as well. It's called the Sinner's circle. It's a German, it wasn't an English name. Sinner's circle. I think, okay, I forgot here the fans, you have usually a choice between a small fan, which is running at high speeds, or a large fan running at slow speeds. If you have the space to do it, choose the large fan with the slow speed instead of the small fan with the high speed. It's physics. Now, less is more. I think it has been discussed many times. Try to do local demand control, and whatever subject you take, it's okay. I mean, heating, cooling, of course, lighting as well, ventilation. In fact, ventilation, the draft regulation for ventilation already puts all these things in there. But also all the communication devices. Also, but when we're talking about communication and information, we're not saying demand control, we're just saying we're calling it auto power down, or we're calling it demand, how do you say, less standby losses, or various stages of awareness of a computer, that sort of thing. But it's in all these areas, it's over there. Yes? She started moving then, I said thank you. Okay. Thank you very much.
Okay, so then now you have the opportunity to ask questions to any of the panel members that may or may not be related to the introduction. In his introduction, Carlos Lopez was asking a few questions that he was hoping that we may get some answers during the day, so we can maybe try to find out if we got some kind of answer. So one thing is that during the presentations and also during the discussions, we saw some examples of product approaches that are already implemented in current regulation. But then also we saw a lot of examples where a system approach would be good for energy savings, but where we don't have any regulation so far. So maybe you could comment on what makes a system, how should we choose systems that can be regulated?
Can I avoid answering that question for a few minutes, but actually perhaps focus the discussion at the same time? And I wanted to ask Niels to display one of the pictures that he showed. Can you put it up there? It's going to blind us, right? Yeah. This is, Niels, maybe you should explain what this is again for everybody.
Oh. Yeah, well, that is, it's a laboratory building anyway. And let's say it's equipment used in typical laboratory building. And by the left-hand picture is the daily pattern, well, the day and night pattern, seeing where the peaks are daytime, but it consumes a lot even in the nighttime. You see the dotted line shows, let's say, the average minimum load. And after retrofitting and optimizing it, you can see that the minimum load has gone down a lot in terms of kilowatts. So the average is actually much less. It still has peaks and valleys, but they're all at a low level. Actually, some of the peaks are a bit higher, but they're probably because they're used at that time, they're needed at that time. I think that is what it shows, how it's more appropriate energy use, and it's adapted to the time and when it is needed.
So, thank you. So, the reason I wanted you to display this again is because I think this illustrates some of the system problems that we have, some of the challenges. Because what we're seeing now is these buildings don't reflect occupancy very much. For the most part, most of the energy consumption now is independent of occupancy, even after the retrofits. And that if we're going to work towards our very low energy buildings, we need to figure out a way to put these buildings to sleep when the occupants are asleep or away. And this requires a systematic approach. And that requires a systematic approach covering many, many products, many different kinds of activities in the buildings. But it's the only way we're going to take that kind of load shape, which is increasingly common in buildings, both in commercial buildings and in homes. Applying a systematic approach will be the only way we can essentially put the buildings to sleep when occupants are asleep or not present.
Could I comment on that? Because Actually, you could have chosen any other slide because with buildings you have the problem of inertia. So if you're looking at what is the best heating system, in Europe I think most people would agree that they are ground source heat pumps with COPs up to 7, etc. Now they are very, very difficult to follow occupancy or even climate change, I mean, weather change, I mean. And so the typical solution would be to have those systems, to have provide a base load which varies very little, and maybe at the beginning of the evening a local heater to drive away the humidity. I mean, that is one philosophy. The other philosophy would be the American way of air heating, where you can have instant change. And you will find that in the south of Europe still. But here is also a question of comfort. I mean, not many people love to have air heating in Europe. And so it's a little bit more complex. I mean, for all other types of appliances except heating boilers and cooling, that would be the typical example. But here there's still some custom-made stuff.
So perhaps this wasn't a good example, and I didn't study it enough, but fortunately Niels presented it. And so if we had somehow removed space heating from that, so we would have just been examining the electricity separate from space heating, I think you still will find, as at least from my experience of seeing buildings, again, mainly in North America, but Japan and Europe too, there's this increasing lack of elasticity of response of the building to the actual needs and in the building. And I think that this is going to be one of the challenges and one of the reasons you need a systematic approach to reducing energy consumption. But we can move away from that if people wish to.
Well, I mean, to your question about whether what we can do to do more on systems, I think one of the problems that we face today is that we've moved really from a kind of bottom-up approach. We've done eco-design, and then we've done labeling, and then we did also buildings, and that has, those instruments have developed more or less independently from each other over the last, whatever, 10 or 15 years. And now we see that these things bump into each other, and we also see that in order to move away from that possible collision, is to really start looking from a systems approach, which means that you have to set system requirements and then not worry too much about what you put underneath that in order to fulfill the system requirements. And that in that way, you would, I mean, I could easily imagine, or not easily, but I could imagine that a member state says, well, look, it's all nice and well to have eco-design requirements for heating and ventilation, but actually that stands in the way of achieving better system requirements. So you might want to say, no, we need a way of setting system requirements, and then give more freedom to come up with products and product requirements that that fit in that system. So it would be actually designing the thing upside down and more top down. But I mean, currently that's not how we do it, and the question is whether we will ever get there, because we would have to get rid of something in order to start from a new place.
Yes, I mean, I guess for some products also, it's more easy to integrate it directly into the regulation. For example, like for the motors, I mean, I don't know, maybe you can comment on that, to what extent it makes sense to say, for example, that an i3 motor is as good as an i2 motor with a variable speed drive. So in that sense here, I guess the system approach is implemented directly in the product approach. Yes, so maybe you can comment on it, to what extent you think this makes sense in that case, and to what extent this can be transferred to other products.
Well, first of all, a VSD should only be used in applications which require variable speed and/or variable torque operation. It's a mistake to use a variable speed drive, a VSD, in an application which does not need variable speed. But assuming we are dealing with this sort of application, and about 60% of all motor applications benefit from having variable speed controls, then the question is if an IT motor plus VSD is as good if the application is genuine and benefits from VSD application. IE2 plus VSD save more than just an i3 motor, that's for sure. But you have another choice for, I would say, for the more ambitious user, is to use a VSD plus an i3 motor. And you have not just the gain between IE2 and i3. You have an additional benefit, that is, when you are driving a motor with the VSD, you have a small increment in the losses because the output of the VSD is a waveform that is not exactly sinusoidal. So I would say that in applications with variable speed requirements and a large number of operating hours, the way to go in a new application is for IE3 plus VSD. But I would say that IE2 plus VSD is better than an IE3. So if you are doing this comparison, what I say is there is a third option, which is even better.
Yes.
Hello, Stefano Aditi from the European Environmental Bureau. Just a question. I'm not so experienced as René on this eco-design, but for the last, I would say, 4 or 5 years, I'm dealing with these policies. I'm hearing about system approach and what we could do. And after 5 years, I must say that I haven't seen any kind of improvement. It's a bit exaggerating. Maybe I came after the motors, and I think the energy-related product will be kind of a promising, maybe first step to really investigate extended approach. But I've got a simple question. It is, we know that we've got a product policy today, and we know that some of the product that will be placed on the market today will be lasting for the next 15 years. And if we consider maybe B2B product, it's probably longer than this, 20 years or something. Is there anything we can, I would say, simply integrate in the regulation on product to be what I will call being future-proof in a way, being able to be compatible with what we know will probably come as this kind of internet things, and then prepare, even if it's hard to have something like a silver bullet solution, prepare things. I just have a few examples, and I'm sorry if I misunderstood them. For example, we spoke about this kind of smart control devices or features we could integrate in product, and the risk that they overconsume compared to what they could save. Would it be feasible to have a kind of, like the standby or network standby regulation, a kind of transversal approach, saying that the product should be equipped with this kind of smart control possibilities with a maximum energy consumption for this smart control? It is a question. I don't know if it's relevant or not. Another things I've noticed is about testing things in part load. And I know that it's not because you test something in part load that it will be immediately relevant to capture the saving, but it looks to me that it's a kind of condition sine qua non to eventually capture the saving at system level. So can we have more systematically the part load, partial load, or different load specified in a way in the eco-design requirement? So you see, kind of modest approach, but starting with something rather than awaiting that we've got the full answer to all the challenge that René properly put on slide this afternoon, and which for me is like a message, okay, we are not ready, and for the next 10 years we will not be ready, which means that I don't know how we can start. So if you've got any idea about this kind of small, modest steps we could do using the product policy we have, and maybe building on the 2 examples I've suggested. Thank you.
Yeah, thank you for this question, Stefano. I mean, I have to put it a little bit black and white, but it sits somewhere in there that there is progress. And especially on the point that you mentioned, Traditionally, test centers did something at a steady state. And at steady state, they looked at the performance and at the same time at the energy. I think from all the eco-design regulations which have been accepted now, most of them, I can't even think of an exception, most of them look at partial load at the moment. Maybe not fridges or something, okay, but that's thermostat type of device. So there is progress there, and we are looking at the circulators who are tested at 4 partial loads, the washing machines which are tested at partial load, full load, different temperatures, and so forth. So basically that's okay. With motors, because it's such a general theme, this is not yet the case, but I'm sure it will come. But let's say 90% of the products where there is an actual application, it's not the horizontal ones, there is partial load. What we are talking about now is to extend from, so there is already progress, yeah, from steady state to variable speed to being flexible, etc. So it's already there. What we see is that it's not perfect, and what we see is that controls are not part of it. So, not perfect, for instance, the boiler regulation stops at 30% part load. For the actual application, it would be better at 10% part load. Why? Because it's a combi. Combi needs 24 kilowatts, the house needs 5 kilowatts. So actually at 30% part load, you're still regulating on-off, which is not good. Okay, so either the turn-down ratio goes wrong, or you have a twin solution with peak load and normal load. I hope somebody followed this. I'm sorry if I too many details. So what I want to say is, with this example, there is room to improve. Yeah, and with every review of all these regulations, we can see, okay, can we make one further step? Can we include more control side? That's actually the situation at the moment. So it's not so negative as I said before. Yep.
Maybe just to add that indeed, I mean, the fact that the methodology provides already for a more systems approach and looking beyond simple use and use phase, I mean, that makes it to some extent future-proof, and then every regulation has a review clause, and that allows for we actually have review clauses even before certain requirements come into force, which is causing all kinds of problems. But so there are ways in which we can amend regulations to make sure that let's say developments in the market or in products can be accommodated for.
If I may, I would like to come back what Stefan just pointed out in terms of the increased lifetime of products, which may have an impact in our discussion, because that's something what we in the lighting sector at the moment we see very clearly. There's the new LED technology coming to the market, which has a much wider lifespan than any lighting product had in the past. Insofar, it's very important when we come to regulation that exactly these intervals, these review intervals, are very, very thoroughly prepared and come to the right time. Because there could be a concrete danger. I don't think it's for the time being out there, but we might fall into this trap that out of well-meant legislation we interfere negatively with the innovation potential in the industry. So insofar, I think we have to really find the right balance between what is there, what needs to be regulated, and that's minimum performance requirements. Also for systems, I think we are not yet there, but I think we're moving in this direction. But there needs to be enough space, enough scope for the innovation, for market competition, and for a level playing field where industry players can actually develop their innovation potential in a competitive environment. So insofar, I think we have to really pay attention that we don't over-regulate in this regard either.
Can you be more specific? Can you give an example of the lighting industry? Where is the problem?
Yeah, we can. Well, we heard this morning we can do this over a beer that we could do as well. But it's a general remark, because I'm not saying that we have this today. No, I'm not saying we have this today. I think the regulations as they stand, the product-related regulations, they find this way in a very adequate way actually. But when we now take a look into upcoming technologies, I could see the risk, and the only thing what I'm saying is we have to be aware that this risk does not materialize.
Mark Allington from ICF. I'd just like to comment, and that's an interesting point, and it was going through my mind before as well. Maybe we need to think about eco-design in a different way when we look at systems, and start to look at more voluntary approaches with industry, and to look at agreeing or negotiating targets with industry. What we've heard from the associations that are presented today is that they see a lot of opportunity to move beyond products and into systems and have a lot of further savings by doing that. But we've also seen the difficulties in market surveillance for those areas, in defining what the boundaries are between products and systems and so on. You know, what I'm suggesting is maybe there's a solution which is around looking at negotiating targets for energy reduction with industry, and then allowing the creativity that you're talking about to blossom to meet those targets.
May I? Negotiating targets with industry. That's. I'm not so sure about that. I'm not so sure about that, because that would mean that the industry is some sort of a privileged stakeholder in the whole exercise. We don't see ourselves like that. I think the more beneficial approach would be that the EU is actually adopting an energy efficiency target. That's not being done for the time being. So the proposal has not been made. Member states are not in favor of that. So this is just the political surrounding where we are in at the moment. We like it or we don't like it, but that's a matter of fact, as we see it. So insofar, I think negotiating targets with a specific industry, I'm not sure if that's the right way. I should not be misunderstood that we would be against regulation. I said this morning that we see a clear link of existing regulation which goes into revision, EPBD and Energy Efficiency Directive, where we would see the lighting system approach adequately addressed if we do it in an intelligent way, which definitely will not be simple. I fully agree on that. Yeah? But insofar, I think it's always a little bit difficult to think about negotiating targets. I think what the industry needs is planning security, and planning security comes from intelligently made, surveilled, and implementable regulation.
So far, from what we've heard, energy efficiency on product level is good, but energy efficiency on system level is even better. And can we go beyond system level? We'll just be in heaven. I understand that, I recognize there are some system where it's obvious that you should make the regulation on the system level. The motors and the variable speed drives is one example. But I think you should be cautious, especially in the Commission, trying to advance to a system level in every case, because as René pointed out, things become more complicated. When the regulation becomes more complicated, it'll be more difficult and it will be much more costly to enforce, and a regulation that cannot be enforced isn't really worth very much. So my advice would be to think twice before you move from product level to a system level. And I would like to mention another thing. Even though we are in the European Union and we are all alike and we have the single market and so on, there are things that doesn't really, where one standard doesn't fit all. We We have the space heaters regulation, but as we've seen at home, that we had to lower our requirement for natural gas boilers, and maybe there are some in the southern European countries that are not really content with the regulation. You might end up with having regulations that everybody is discontent, has a discontent with, or a discomfort with. So I think, wouldn't it be possible to introduce climate zones or other kind of differentiation within the in the Ecodesign regulation, which, so to say, loosen the relation between the regulation and the requirement of the internal market?
I just want to say something about, Robert should react, but I just want to say something about your idea about the climate zones. I think this is a wonderful idea, and we have made proposals for that, also in the context of studying for Lot 1, for the space heating boilers. And I think there is a true potential there to unite Europe in really respecting every country's existing climate zones in their building regulations. You can make one system of climate zones for the whole of Europe. Yeah? Okay, maybe Germany has, I don't know how many, 23 climate zones, so maybe they have to give up one or two. But apart from that, you can do that. But again, so there's a rationale for that. But what we see, and this is one of the big problems, is that every country has people who do not want to give up their national climate zones, because that's what it would mean. And you know about that, so actually the question goes a little bit back to you. How would Denmark feel if they had to give up their climate zones for a European uniform system of climate zones? Okay, but I leave the rest to Robert.
No, I mean, the only thing really is to thank you for the advice. I think that we are thinking twice, we are thinking 3, 4, 5, and sometimes 10 times before we propose certain things. And in effect, the Commission is only one, I mean, not minor, but one of the players in this whole game, of course. And I'm very happy that we go through a quite elaborate process, which is well established, where stakeholders have all the opportunity to contribute, to comment, to disagree and agree. And subsequently, we have the member states that come to a regulatory committee, at least in the case of Ecodesign, and vote or not in favor or against certain regulations. So, I mean, I think this is really a shared responsibility. This is not just the Commission proposing wild systems regulations. On the contrary, I think that we go through a well-established process where there are lots of checks and balances that industry, other stakeholders, and member states can use in order to avoid that we come up with all kinds of extremely complicated and not enforceable regulations. Having said that, I agree with you that we have to think a few times. Maybe we have done, yes. But overall, I think this is not purely the Commission enforcing its will on poor member states that then have to simply implement. That's not really the situation as I see it, at least.
Carlos, you want to?
Please. No, well, I wanted to speak about the problem with, if somebody thought that there would be just one approach to approach systems, then I think that that person would be wrong. So systems, the system approach is exactly that they are all different. So it's very good that the MERP now is very flexible. It has to start by analyzing which systems, and of course it will be a different solution. So the difficulty is that it's much more work than there are. What we know also is that when the preparatory study is finished, then it's not that the Commission has a proposal. That sometimes we say that we should put the level of the requirement at the least life cycle cost and so on. Actually, people forget what was decided, what was calculated analytically in the preparatory study, because then it becomes a a negotiation, and the negotiation is just a negotiation between actors, and it's not analytical anymore. So I think that we will have to be prepared to have longer discussions with many more actors, and that will require a lot of capacity from everybody involved. And I think that the Commission will not have that capacity. So they will have to be helped by member states' representatives. We know that the industry will be there always. But now, with the problem, if we go for delegated acts, then we will have 10% of a person in the Commission negotiating with the people from the industry, which are very professional, and with 10% of a person from the Commission, it will be very difficult. So I think that and I can say that when we are going to delegated acts, it will be very difficult, for example, for me to convince my ministry to give me enough resources to say, I need those resources, but you don't even vote. So what are you going to do with the resources? So if we are going to delegated acts and we lose our votes, I think that the Commission will have a very, very hard time. And unfortunately, the system approach that we have discussed today will be in danger, I would say.
Hans-Paul Siderius, Netherlands Enterprise Agency. That to many of you sounds like a new name. It is, but I'm still doing the same. I'm still working on eco-design and energy labeling. Today, and I think already this morning, I think there are many useful things said about both the relation between products and systems and different pieces of legislation. I think what we should be cautious of is to find a single piece of legislation that can solve all our problems. And I think during the day in some of the presentations, I think there might be suggestions on, and Robert said it already also in this panel discussion, to connect better eco-design energy label with, for instance, EPBD, but maybe also with EED, RES, and other legislation that also influences products and systems. And the approach then, the approach for eco-design energy labeling would then not be per se to go further into the systems area, but to make the design pieces of legislation or work that can be used as a kind of building block in these higher level, so to say, legislation. And I think already two examples were shown today. First is the installer label, where the installer builds from the ingredients, the different products that he or she puts into a package, a label. The other one was by Annibal, I think, for the motors with the energy efficiency index, where he also combined different components or different products into one index. So in thinking about eco-design and energy labeling, then the idea would be, yes, we have to take into account systems because products are becoming ever more connected, and so we cannot avoid that. But we should think twice whether in our requirements and regulations, how far we go, and whether with more simple eco-design requirements, but with good information, we make it more easier for other, say, higher system level legislation like EPBD to make use of these components. And regarding climates, Peter, do you know how cold it is in mid-Spain?
It's cold in the winter, I know
that. I just wanted to say that I think that you're absolutely right. I think Jeff Harris said something a couple of years ago, like, if you've got a hammer, everything looks like a nail. And this could be the case in eco-design as well. We have here an instrument which is mandatory, which is attractive for policymakers. We have another instrument, EPBD, which has some non-mandatory aspects. I don't want to go into details, but it's been really tough to get some progress there. So the solution obviously is we put everything under eco-design. And I think that you're absolutely right. You should, in an ideal situation, have 3 or 4 instruments at various levels looking into this. And that would be the ideal way forward. So rather than saying, okay, we just put everything under this one instrument, the question might be, how do we promote the other instruments to be at a level footing with eco-design as we perceive it to be successful? The second thing, and I've said it to some of you individually, the installer label, and I really think is a very dangerous name. It suggests that every installer has to put a label on every boiler and every component of a heating system. I don't know how it is now in the regulation. I can just tell you that historically that was not the intention. Historically it was that there are those installers, big firms, which almost act like a sort of manufacturer, who felt threatened by the fact that real manufacturers were then the only ones who could get credits for controls and stuff like that, who said, please, 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 could you make something for us so that we are not left in the cold? And as they are small and medium-sized enterprises, politicians listened and the installer label was born. So I don't know how it's now interpreted in law, but that was the origin of the installer label. I hope that is clear.
Yes, maybe a bit provocative question, and relates to the last thing René said on installer label, but also on some of the complexity we have in going for system approaches. If there's a mandatory system requirement, or there is to be a mandatory system requirement, whether in Ecodesign or in other legislation, how can we avoid placing responsibility for compliance with the system requirement on the economic actor with the least capacity for dealing with bureaucracy, dealing with declaration of conformity, dealing with liability for this. Mainly small enterprises that are the actors integrating systems, putting systems together from components. One way would be using prefabricated systems, like packages, and one, but that's exactly the fear that René mentioned, that this takes away some of the liberty from installers, from systems integrators, when choosing components or when combining components. So how can we deal with this this dilemma of placing the responsibility for the most complex requirements on the smallest actors?
Maybe an observation on that, because I think that's a very valid question. On the one hand, or remarked. On the one hand, you said the installer is responsible for choosing the equipment and the product. That's absolutely clear, but this in a surveilled market, the product is compliant with the Ecodesign legislation. So insofar that there already, I think there is a certain a certain relief for the installers. He or she, they must be, it must be reliable. They must rely on a situation that the product what they choose is absolutely compliant with the European legislation. That's number one. On the other hand, of course, I mean the installer at the end of the day. Well, I don't speak on behalf of the installers, but surely in the contractual relation between the client and the installers, it may be the case that the responsibility is with the person or with the company who has installed the system. But this is already today the case, and I think we should not underestimate the capacities of electrical installers. I think for them, it's a very, very creative profession. They know the business, they know the things they're talking about, they know the things that they sell. So far, as soon as they act or can act in a reliable situation, a reliable framework, that the products they choose are compliant, and they are not left alone with uncompliant products in an unsurveyed market. There we are going down to, in my opinion, where the fundamental problem of Ecodesign also is. It is about market surveillance. It is about market surveillance. And before we don't address this adequately, I think we can discuss a lot about system. We can discuss a lot about the next steps, and rightly we should do so. But we will not have the impact on the savings potential what we actually could have when we take it serious that only those products who comply with the minimum performance requirements or are on the eco-label or similar schemes are top runners. Also there a surveillance scheme is necessary. It is important that the purchasing choice is one which can be made with best conscience because the market is surveilled, because the market is functioning. So in so far that was a side remark, because I think the observation is absolutely right. The problem is definitely there.
Thank you. Just going a little bit back to the beginning of the discussion, the gentleman said from the Commission and also the gentleman from England. It was interesting. I mean, for us, working in industrial energy efficiency, so we don't know really about occupiers, but it seems the people are the problem always in the system. And we always think about technologies which we can kind of cover up, with the inefficiencies of the people being involved in either industrial process or the buildings. It seems so. It's sort of, we are dealing with the industrial boilers, we're dealing with the pumps, we're dealing with the motors, we're doing the insulation, we're dealing with energy management systems, and it seems, more and more, if you take a system approach, it's sort of, devil is in the details, really. But why not really sort of avoid the devil and try really sort of to reverse engineer the systemic approach to have kind of eco-design reversed. So if you look, draw a top line, and think about, let's have a benchmark. And then basically for the operators or people running the factory, they can decide themselves, really how they can match the benchmark. You can also, they can bring, behavioral change, they can bring people, they can invest in new equipment, but they don't need to invest in new equipment. Thank you.
I don't know if this question was specifically addressed to me, but I mean, we have experience, for example, under the IPPC directive, where this is happening. We have best available technologies, and that is then used to set benchmarks, and that becomes then the driver for innovation and change in industry. And so something similar could possibly be picked up also for industrial energy efficiency, when you start to look beyond individual products, if that exists already, and you look at systems within the industrial context. I think for the time being, we have collectively opted for what we have done in the Energy Efficiency Directive. It's basically saying, look, if you are a big company, you should do energy audits, and you should look at your entire energy consumption, whether it's in buildings, in your systems, et cetera, and then come up with ideas and ways in which you can improve that. And so it is taking a management systems approach to something where I also think it would not be so efficient to do it more bottom-up and start tackling individual users of energy within an industrial context. So I think that is already kind of happening. And if you look at what we are, when we're looking at machine tools in the context of a voluntary agreement, for example, colleagues from DG Enterprise, and you see that that runs into lots of problems because, what is a machine tool? I mean, and so it's very, very difficult to approach it from a product's perspective, I would say.
Well, I wanted to comment on the challenge that when you go to more complex products, and even worse when you go to systems, it's true, as Peter said, that we will have to invest much more in market surveillance. And not only market surveillance, but also in standardization. So I think that there the Commission has to issue some mandates before we can do something, especially when we see that it's 120 years to have a test for motors. So, and that means also that market surveillance is going to change totally. We're going to go from testing products in the lab to have a kind of documentation control to assess the conformity, and that will be probably using the module. So we will go from internal design control to something closer to third-party verification. And then maybe we will have a problem, is that market surveillance authorities maybe will say that if there is third-party verification, that we are not needed. And that's also a huge danger. So what I think that we will have to do is that to get more synergies with other policy instruments. Now I'm thinking, for example, with the certification of installers in Article 14 of the Renewables Directive for installation of systems using renewables, that those will help to increase the capacity of the installers so that they will be able then to leave the so-called installer label. So I think that we will have to use much more synergies and to not speak only about eco-design. And I think that sessions like today are very important to try to work more together. And that's also what we can expect for using more information requirements so that we can make a better use, for example, Article 6 in the Energy Efficiency Directive. So I think that, or green public procurement. So I think that there are lots and lots of synergies that we have to explore in order to help different policy instruments to get a better implementation.
Maybe just quickly to react, I agree. It's clear that if you move from a product that you can pull off a shelf and send to a lab and have tested in a day or two, then that's a fairly straightforward situation also for market surveillance. We already today have a situation for buildings where this is the case, where there's supposed to be market surveillance for buildings because every new building needs to comply with minimum energy performance requirements that are set by member states based on a national calculation methodology, etc., etc. We know from experience that that is not happening. And you can argue that building is the ultimate system to some extent, because all of these products that we eco-design are in there. And already there, you see that member states struggle with doing proper market surveillance, and we have systems of certification of the people that do the energy performance certificate. We have systems for people that do the testing of the heating systems and the cooling systems, and we have all that in place. And there are really only a handful of member states that have tackled this, I would say, properly from the start, from the inception, I would say, of when this was implemented at national level. And of course, if we move to systems under Ecodesign or any other instrument, we would have to think about similar ways in which member states can undertake proper market surveillance, because otherwise it's a paper tiger. It's nice on paper, but it doesn't work in practice. And then I'm talking new buildings. Think about existing buildings that undergo major renovation. What is happening there? Zero. There's zero control happening there. There it is.
Yeah, it is a very broad question, maybe too broad. But I attended a conference about carbon taxation recently, looking at British Columbia and the fact they have an energy tax there, and it's quite a high energy tax, and it's resulted in a lot of reduction of carbon emissions there, and they offset that against income tax, so it's revenue neutral. Apparently when the EU and other countries looked at that, they didn't consider it revenue neutral, but the point being, if we were to, as a region of the world, correctly price energy and tax energy, then I think you wouldn't need to worry about systems or products, because every individual will work out for themselves that it's really expensive, they can't afford to use energy, and you wouldn't have all these technical difficulties. Okay, another subject altogether, but surely that would solve a lot of problems if you just were to tax energy properly.
I'm going to answer that because I strongly disagree. And the examples will start with the set-top box. Essentially 100% of the set-top boxes are purchased by entities that are not going to pay for the electricity consumption. Jürgen spoke about in the lighting industry that there's so many cases where there are one entity is the purchaser and the other is that pays for the electricity consumption. And that, contrary to what economists will tell you, which they say, oh, these are minor imperfections, minor market failures, and the market will fix them on their own fairly quickly. These are constant and chronic kinds of problems that exist throughout all of the buildings industry, some of the appliance industry, and so on. Every time anybody builds a building on speculation, their job is to minimize the first cost, and they don't care about the eventual purchaser. And the International Energy Agency did a study of this several years ago, which I led, to try to quantify the size of these market failures, of just these landlord-tenant kinds of situations. And depending on industry, it's either very small or 100%. It just ranged from there. And they were not going to be solved overnight by the market. And so you need a role for the price of carbon, or whatever it is, the price of changing the price of energy is an important signal, but it's not going to be the only signal that will deal with it. There are many situations where you need to use other policy tools.
Just very shortly that what has been addressed by Hans Paul and by others as well, and it missed from your presentation, Robert, the EU Energy Star program. So we are talking about, because we're treating all products the same, but it's not true. You have very local products like buildings, but you have very global products like electronics products. And actually, maybe people would not agree, but the Energy Star in general, for office equipment, has been highly successful in focusing those manufacturers on something which they might not have focused on without Energy Star. Starting with the US, putting all their buying power behind it, they could just as easily could have gone in their R&D not towards energy efficiency, but towards, I don't know, more fashionable designs on the outside. They didn't. Why? Because there was a strong signal, commercial signal, that's the way you have to go. It doesn't mean that the products became more expensive or whatever, they just become spectacularly more efficient. I've seen figures here about electronics going down 17% and then 35% with system approach. Sorry to say that, that's not true. It's much more than that. The efficiency of televisions is going down 90% from a single product approach. Imaging equipment, 90% or more. And just because there has been a strong commercial focus, organized globally, okay, look at efficiency, guys, otherwise, you know, we're not gonna buy US government your stuff anymore. So just to mention that there are products, it should be tailor-made, there are products where you could do different things than, for instance, with building systems, where we're talking about all the time. Sorry.
Yeah, thank you. You've discussed several challenges or barriers to address systems, some technical, some legal. Now I'd like to ask whether there is a real and genuine political willingness to regulate system and installations. And I'll take one example. I don't want to blame our host. I want to be clear about that, no offense, but Jürgen Sturm mentioned this morning the lighting installation in this building, in this room, and said, well, there's no occupancy sensor, there's no daylight sensor. So the question is how we make sure that this is put in place before the next refurbishment of this building in 30 years or 40 years. So that means that at some point, the owner of this building will receive a letter maybe saying, now you have to implement this, or there will be an inspection and telling him you have to rebuild the lighting installation of this building. Do we agree that this is what we want and the way to go? And is there the political willingness to do this? Because for many systems, we will need to have this kind of approaches.
I'm not sure I'm the right person to answer this question, because I mean the Commission is not really a political body, as you know, and the political decisions are being made by the European Parliament and the European Council, where member states are sitting. So those people would have to really answer these questions. And I mean I can really only kind of take implications from what, for example, Peter was saying, that the Commission has to think twice or more when we go to systems, because it is more complex and we need more capacity. And so there is, outside of the political question, there is this technical question which I think we have to deal with. Is there political willingness? Based on the experience that we've just gone through in the negotiations on the Energy Efficiency Directive, one has to conclude that there is not so much political willingness, or there was not so much political willingness at the time when the EV was negotiated, to go very far in that, I would say. I mean, we started off, member states started off clearly opposing binding targets for energy efficiency. And then throughout the process, we almost came full circle where they even weren't that happy with all these binding measures, and they were saying, well, maybe we should have had binding targets, because that would at least have given us the freedom to design the policies as we wanted. So it's funny to see how that went round, and I'm very curious to see how it will go forward. I mean, it was mentioned that in the recent communication of the Commission there was no mention of an energy efficiency target, which obviously is true. In the middle of this year we are going to come forward with a review, or at least with a status on where we are towards the 2020 targets, and we hope that we will have room in that context also to start talking about 2030. Whether that's proposing binding targets or not, I don't know, and nobody knows for the time being, I would say. But it's clear that as long as there is no real political willingness to tackle this at a systematic level, if I can say it like that, it's going to be very hard, because then we are going to be forced to do it through existing instruments from a more bottom-up approach. And I don't think we have concluded, but we've seen that there are limits to that, and it might not be the best way forward. So I think a systematic approach to all kinds of issues would be best. Let's take an example, which is the building renovation roadmaps that we have proposed in the Energy Efficiency Directive. If member states take that and to implement that seriously, then that is the perfect systems approach. You look at the building stock at national level, new buildings, existing buildings, you say, where do we want to be in 2050, and how are we going to get there? And what do we need to do in terms of implementation of the EPBD, of our eco-design measures at European level, of financial instruments supporting that, of green public procurement, of all these kind of things that are already in place. So I think to some extent the tools are already there. It is really depending to some extent to the willingness of individual member states to take the tools and use them as best as possible and as ambitiously as possible. And so, yeah, that's what I want to say about that.
Okay, I think we should finish with that, and thank all the panelists. So Before the concluding remarks, I would like to thank all the speakers and also all of you for the very interesting discussions. After the concluding remarks, we have a reception outside with some food and drinks, so it would be nice if you could stay for that. With that, I give the microphone to Pernille. Okay.
So now that Sibylle has taken care of the first point I was going to make, we can be very efficient and move on to the next. I was wondering who was going to do the concluding remarks. Now I know. I'll try and be quick and not take up too much time before drinks are served. But I'll make a few points and then I will conclude with a new prize, a new CLASP prize, which I will be awarding. It will be purely symbolical, the prize, but I think it'll be important. So the good news, I think we heard, is that there is a large potential for making additional savings. From Nils's slide, it looks like it's as much, again, as what we expect to have from the current Ecodesign directive. So that's great. However, the next question is, how can we turn these potentials into actual saving? Always a tricky one. And in my mind, there are at least two questions that quickly arise. One is, how much of this, as Jürgen would say, theoretical potential is vulnerable to the user interface? Then I think the next question in my mind would be something along the lines of, from a public policy perspective, how much of that potential is available from different types of instruments? How much from regulation? How much from some of the other tools in our toolbox? And I would sort of step back and think about the Commission's lighting invitation to discuss a lighting strategy. I guess until today it was probably more in my mind something about lighting products, lighting widgets. But if you shift the perspective around and think about lighting services and say, okay, well, all right, this is about a more coherent approach to lighting services, bringing down the energy used to deliver those services very significantly. Then you can also try to sort of bring in a larger set of policy instruments and not just focus on the Ecodesign and energy labeling directives, which I think is very much how the discussion here has been going, which brings me, I think, to the next point, which is about the scope for dealing with systems in the current legislative framework for ecodesign and energy labeling. And I think what I get from René's presentation is that there is scope, and maybe there's even sufficient scope, and while we might think about whether there's a need for twigging the existing regulatory framework in the context of the review, it's more to do with how that interacts with other types of regulations like the EPBD, such as the points that Peter was raising in his presentation. And so maybe the challenge is to secure a better fit between different types of instruments. And that was, in fact, my next point. So then, following on from that, I think what's been raised on a number of occasions is the issue of complexity. With systems, we have more complexity. We have exploding data requirements. I think that was René's point again. And we also, I think I would add, have a potentially exploding number of actors who are involved in delivering the savings, either in or out of regulation. And then we have the not insignificant complexity of delivering adequate measurement methods in a suitable time frame. And the additional difficulties raised by systems when doing adequate enforcement and ensuring we have a suitable level of compliance. And we know that on both of those latter 2 points, we are facing challenges within the system as it stands. So extending out to more systems put pressure on known challenges in the system, I think I would argue is what is coming out of the discussion today. So then, to the takeaway prize, I think there's a lot more that could be said, but to cite someone else, I think it's again you. We can take it over a beer, perhaps. in the reception area, and drinks will be very shortly served. But the prize, I think, goes to René Kemner again. It was when you said, we need to do something really true, but it also needs to be really accepted. And I thought that was quite a good note to end on. So thank you very much for all your intellectual energy all through this day on behalf of all of us who have organized. Thank you.